All right, let's talk about a huge idea in AI. What if the biggest problem with AI today isn't that it's not smart enough, but that we can't really control it? We're going to break down a fascinating new framework that proposes a solution, a missing control dial that could change everything.
And this quote from researcher Adam Marblestone just nails the problem. See, we are fantastic at making AI bigger, piling on more data, more computing power. But the human brain has this secret sauce that lets it learn incredibly well from just a tiny handful of examples. So, what are we missing? So, here's our roadmap. We'll start with that secret sauce problem. Then we'll introduce a new way of thinking about it, the CMAC AI framework. We'll dive into its two key parts, a stabilization dial called kappa and a context map called the K-field. And then we'll see how this all becomes a real-world plan for building better AI and what it means for the future. Okay, let's get right into it. The core issue we're facing today isn't just about scale. It's about why our massive AI models can be so inefficient and, honestly, so bizarrely unpredictable. Think of it like this. We're building these gigantic, powerful engines, and they get more powerful every year. But we've been so focused on horsepower that we've kind of forgotten to build a steering wheel or a proper brake pedal. That's the secret sauce, the brain's built-in system for handling values, rules, and rewards that gives it fine-tuned control. So how do we find that steering wheel? Well, that brings us to a framework that gives us a completely new lens for this problem. Instead of treating weird AI behavior like a ghost in the machine, CMAX AI says, no, there are missing variables here, and we can define them. And here they are, the two big ideas. First, you've got K, which is basically a structured map of the world for the AI, all its context, values, and rules. And then you have kappa, that's the Greek letter K, which acts like a stabilization dial. It's the control system. Together, K and kappa might just be the secret sauce we've been looking for. Okay, let's dig into that first piece, kappa, because this is a really fundamental shift. We're used to fiddling with a bunch of different knobs on our AI models, like temperature, hoping to get the right output. This is different. Kappa is designed to be one single master dial that predictably tunes the AI's entire mode of behavior. So what is it really? Well, imagine an AI is considering 1,000 different ways to answer your question. Kappa is the parameter that controls how decisively it picks one path and sticks to it. A low kappa means it keeps all its options open, exploring everywhere. A high kappa means it locks onto a single, coherent idea and commits. It's basically a dial for the AI's confidence. And this table just lays it out perfectly. When you turn kappa way down to 0, the system goes into full-on exploration mode. It's divergent, creative, but it's also where you get hallucinations because it's not committed to reality. Crank it all the way up to 1, and the AI becomes rigid, stable, but brittle. It can get stuck in a rut, refusing to deviate, which is what we call mode collapse. And somewhere in the middle, that's the sweet spot. So you see the trade-off, right? It's not random. It's a clear spectrum. Low kappa gives you creativity, but it comes with instability. High kappa delivers stability and predictability, but it can make the model overconfident and brittle. For the first time, this gives us a way to manage that trade-off between exploration and exploitation with a single, understandable control. Okay, so we've got our control dial, but what exactly is it controlling? Well, it's managing the AI's behavior within a certain context. And that brings us to the other half of the puzzle, defining what context even is. It's not just a string of text, it's a whole structured environment. And that's the K-field. This is a huge idea. It says that context isn't just the prompt you gave it. No way. It's this formal, multi-layered object that holds everything. The AI's background knowledge, the specific rules for this task, your conversation history, everything. It's the entire world map the AI is using to navigate. And here's the brilliant part. It's not just one big blob of context, it's broken down into layers. K1 is like the AI's DNA, everything it learned in its initial training. K2 is the instruction manual you just handed it for this specific task. K3 is the short-term memory of your conversation, and K4 is the real-time feedback loop with you. Now, if an AI is ignoring your instructions, you can diagnose why. Maybe it's memory. K3 is overriding the rules you set in K2. Okay. This is where it all comes together. Theory is one thing, but this is about building a powerful tool. When you combine the K-field with the kappa dial, you suddenly have a new way to understand and fix some of the most annoying problems in AI today. And this is the real payoff. All those common AI failures can now be seen not as weird bugs, but as predictable states of miscalibration. An AI hallucinating, that's just kappa set too low for that specific K-field. An AI that just keeps refusing to do something? Probably kappa is cranked too high with really strict rules in its context. This turns debugging from a guessing game into something more like engineering. So that brings us to the CRF LLM. If the CMAC AI framework is the theory, this is the blueprint for how you actually build it. The CRF, or CMAC reward field, is basically an agent designed from the ground up to have a structured K-field and an adaptive kappa dial. It's a system built for control. And the best part is, this isn't just a wild idea. There's a tangible 3-phase roadmap to build it. Step 1, prove the K-field works on its own and can reduce bad behavior like reward hacking. Step 2, add the kappa dial to gain stability and control. And step 3, scale the whole thing up to tackle much more complex real-world problems. It's a clear path forward.
So let's just pull back for a second. What does this all mean for the future of AI? Well, it's potentially a massive shift away from how we've been trying to control these systems so far. I think this is the core takeaway. For the last few years, we've been practicing this strange art of prompt engineering, basically trying to find the magic words to get the AI to do what we want. This framework is about moving beyond that. It's about turning that art into a science. We're going from being prompt whisperers to being true system engineers, building predictable and reliable AI from the ground up. This quote really just wraps it all up perfectly. The biggest bottleneck for AI right now isn't the architecture, it's the vague, fuzzy way it handles values and rules. The K-field gives those rules a proper home, and the kappa dial gives us the control we've been missing to manage how the AI operates within that world. And that leaves us with a really powerful final thought. If we actually get this control dial, the ability to make an AI more creative or more rigid, more cautious or more bold, then the responsibility really shifts back to us, the builders. The big question is no longer just what can AI do, but what kind of world, what kind of reality do we want to stabilize? Thanks for tuning in.